Hello, welcome to Gavin Lon Digital. My name is Lon. This tutorial is an introduction to C-Sharp and is the first part of the C-Sharp for Beginners course. In this tutorial, we'll complete a very basic C#.NET application in order to get acquainted with the language. But before we leap into writing code, I'd like to briefly tell you about the technologies I'm using in this course. Although I'll look at a few code editors for macOS and Windows platforms, I will mostly be using Visual Studio 2017 for Windows Community Edition and running this on the Windows 10 operating system. Visual Studio Community Edition for both macOS and Windows can be downloaded free of charge. I've included the location of where you can download Visual Studio Community Edition in the description below. There are licensing terms associated with downloading the software for free, which I recommend you read, but for the purposes of an individual learning a .NET language, it is perfectly legal to download the software free of charge. Visual Studio is an IDE, which stands for Integrated Development Environment. I'll be using the latest .NET runtime, which at the time of writing this tutorial is .NET Core version 2.1. This can also be downloaded for free. Details of where you can download this .NET runtime have been included in the description below. We'll briefly discuss the .NET Framework and the significance of its evolution to the .NET Core runtime later in this tutorial. Code and related documentation created for this tutorial can be downloaded from my GitHub repository. Please see the details of my GitHub repository in the description below. First, I'd like to demonstrate the project creation process using Visual Studio 2017 Community Edition for Windows. We first launched Visual Studio as administrator, so I'll right-click Visual Studio, shortcut icon on my desktop, and run as administrator. Then we go to our File menu, New, Project. We can now see our new project dialog box, which contains a variety of project templates. These project templates can be used to create many different types of applications. For example, desktop applications like Windows Presentation Foundation or WinForms applications, universal Windows platform applications for multiple Windows devices, web applications like MVC, which stands for Model View Controller, mobile applications using Xamarin Forms for iOS and Android platforms, cloud-based applications for MS Azure. There are also many other project types available. The details of the various project templates are beyond the scope of this tutorial, but I hope that gives a basic idea of the types of project templates that are available. Project templates help the developer get started with a particular type of project. Project templates can be categorized under their relevant .NET programming language. So let's take a look at some of the .NET programming languages: C#, Visual Basic, C++, and F#. Right, let's take a closer look at the C# section. As you can see, we have two options for the C# console project: console application for the .NET Framework runtime and console application for the .NET Core runtime. If we were to select the console application for the .NET Framework, we can also target which version of the .NET Framework we wish to use in our application. We can further drill down into subcategories, and the one of interest to us is .NET Core. When we click on this, we can see all the project templates available for the C# language and .NET Core runtime. So we are going to create a console project using the .NET Core runtime. We must give the project a name, so we type in the name field, hello name. As you can see, the solution field is updated automatically with every key press, but you are able to differentiate the solution name from the project name if you wish by manually updating the solution field. A solution can be comprised of one or more projects, but we are going to develop one project for this solution, so we'll keep the solution name the same as our project name. Right, let's press the OK button to create our .NET Core console project. This application is very basic. The traditional thing to do with an introduction to a new programming language is to create a Hello World application. If you aren't familiar with this application, its function is to output the string value Hello World. As you can see, the Hello World code is generated for us by default. We want to create something ourselves, So let's do a slight variation on the Hello World application with our Hello Name application. This application prompts the user for his or her name, then outputs hello followed by the name entered by the user. First, let's get rid of the automatically generated Hello World code. Let's write our code to prompt the user for his or her name. Then the code that will pause the command prompt and wait for the user to enter his or her name. This code basically waits for the user to press enter, then inserts the user's input into the variable we have created, the name local variable. We then output the value to the screen, hello, followed by the value stored in the name variable. The console.read key line is there to keep the console screen active while running our code from the Visual Studio IDE, until the user presses any key which will close the console screen. If we did not have this line of code, the IDE does not keep the command console active, and the code runs straight through and we won't be able to see the final output of the application. Let's test our application. To run the application from the Visual Studio IDE, we can simply press the play button on our toolbar. As you can see, the command prompt is displayed to us. First, the prompt to enter our name. So I'll type my name, Lon, then press the enter key, and the output is hello Lon, which is as expected. Then we can press any key to close the command prompt console screen. Let's examine the code here and modify a few things to test the rules enforced by the CSharp compiler. First, let's remove the string array argument passed into the main method by default. The string array argument is intended to contain command line values. What happens if we remove this parameter and then run our code? The CSharp compiler doesn't mind this. Let's edit the namespace and the class name and then test the application. Compiler is okay with this too. Now let's change the name of our static main method and test our code. The compiler flags an error. Let's look at this error in our output window. Program does not contain a static main method suitable for an entry point. And in our error list we see the same error message. So it is important to note that every .NET project must have at least one static main method, because this is the entry point of our application. The main method is the entry point of a C# application. It is where the program control starts and ends. Note that the exceptions to this are class library projects and Windows Services projects, which don't require a main method entry point. There can only be one entry point for a C# application. Main is declared inside a class or struct. Main must be static. The enclosing class or struct is not required to be static. Main can either have void or int return type. The main method can be declared with or without a string array parameter that contains command line arguments. What happens now if we comment out the top line of our code, which is a directive to indicate that we want to directly reference types that reside in the system namespace without having to include the namespace each time we refer to the type in our code? In this particular case, our type that is affected by this is the class named console. Commenting out the code will ensure that the compiler does not recognize the commented line as code and will ignore it. We now see red squiggly lines under every reference to the console static class, and if we hover our mouse over console, the code editor reveals a message stating, "The name console does not exist in the current context." And now what happens if we try to run our code? It will not compile. An error is flagged. In our output window, it states the name console does not exist in the current context, and it states this 4 times, one for every time we've tried to use the console static class. In our error list, again, the message appears 4 times, once for each time the console static class appears in our code editor. To eliminate this error, we can type the system namespace followed by the full stop character directly before each reference to the console static class, and this makes the red squiggly lines disappear. Let's run the code and see if the error has been eliminated. And it has. The code runs as expected. Now let's take out the comment characters, the 2 / characters before the using system directive at the top of our code editor, and then test our code. This works as expected. but the system namespace included before each of our console static class references is now redundant, so we can remove this. Let's take a closer look at our code. We have the directive at the top which states using system. This directive enables the developer to directly reference types, for example classes, organized under the system namespace without preceding the type name with its namespace every time the type is referenced in the code. Creating our own namespaces can be useful in controlling the scope of types in larger projects. By default, a namespace has been provided for us in our console application code. This namespace is by default the same as our project name, Hello Name. As demonstrated earlier, we are able to change this namespace name. Here we have our static main method, which we have discussed. It is our application's entry point. And here we have the console static class, which is a member of the system namespace. We are able to consume the console class method without preceding the class name with the system namespace because we have included the using system directive. C is a programming language developed in the early 1970s by Bell Labs. Syntactically, C# is based on C. Examples of other programming languages based on C include Java, JavaScript, and of course C++, which is a direct evolution from C. Let's look at the difference in syntax between our Hello Name code written in C# and its counterpart code written in Visual Basic. Visual Basic 1.0 was released in 1991. It was based on the basic programming language and was developed to be more human-readable and was created primarily for rapid application development. One important thing we can see if we look at the Visual Basic code a little bit closer is that the name variable has its first letter, the letter N, in uppercase, whereas when it is referenced later on in the code, it is referenced with a lowercase n. This works okay in Visual Basic. Its compiler sees the name variable with an uppercase n as the same as the name variable referenced with a lowercase n. Visual Basic is not case sensitive. Let's take a look at what happens if we try this in our C# code. You can see the name variable now has an uppercase n when it is defined, and when referenced later on in code, it has a lowercase n. The C# compiler flags this as an error, and the error message states, the name variable with the lowercase n does not exist in the current context. This is because the C# compiler views name with an uppercase n as a different variable to if it was defined with a lowercase n. The compiler is therefore flagging that the name variable with the lowercase n has not been defined. As with C, Java, JavaScript, and C++, C# is a case-sensitive programming language. I want to demonstrate writing our code in a slightly different way. We are currently using C# version 7, which at the time of writing this tutorial is the latest release of C#. Implicit local variable typing, achieved by using the var keyword, was introduced in C# version 3. We can explicitly declare the name variable with a specific type. In this case, the type is string. And then we can remove the var keyword because we no longer need to imply what type the local variable is through the context of this line of code. It is considered a local variable because it is defined within the method, and its value can only be accessed from within the method in which it is defined, so its scope is limited to the method in which it is defined. The dollar symbol before the string literal essentially indicates that we'd like a variable value to be included inside our string literal. This is called string interpolation. To do this, the variable name must be wrapped in curly brackets within the string literal. String interpolation was introduced in C# version 6. We will now replace the string interpolation with composite formatting to implement the same functionality. Let's test our code. The code works as expected. String interpolation and the var keyword provide the developer with a neater way to express the code. So we'll continue to use these convenient coding innovations during this tutorial. I want to briefly cover the .NET runtime. At this point, I would say you don't have to have an in-depth knowledge of the .NET Core and the .NET Framework runtimes, but I think at least a rudimentary knowledge is necessary when learning a .NET programming language. If you are not familiar with some of the terminology mentioned in this section of the tutorial, don't worry, as this is only meant to provide you with a broad and up-to-date context for the C#.NET programming language. I'll provide a more detailed tutorial on the .NET Framework and .NET Core runtimes in the future. Let's go back in time to the end of February 2002 with the first release of the .NET Framework. This is when C# was first released. It is a new, fully object-oriented general-purpose programming language. Visual Basic, through its .NET evolution, has been upgraded from a largely event-based language tightly coupled with the Visual Basic 6 IDE to a new object-oriented version of itself called Visual Basic.NET. A managed version of C++ could also run within the .NET sphere. New languages like F#, which was first released in 2005, could also run within the .NET environment. These languages are all interoperable, which essentially means, for example, a C# application can consume a .NET component written in Visual Basic, or an application written in Visual Basic can consume a component written in C#. What makes this possible is the Common Intermediate Language, or CIL. All high-level .NET programming languages like C#, Visual Basic, C++, etc. are first compiled into the Common Intermediate Language before further compilation into machine language by the Common Language Runtime. All code that runs within the .NET runtime is considered managed code. The .NET runtime also makes available a number of libraries that can be leveraged by our custom .NET code. This is essentially done through a library of files called the Framework Class Libraries, or the abbreviation of this, FCL, which provide generic functionality for our applications to consume. The Common Language Runtime, or CLR, can be described as the .NET virtual machine and provides services like just-in-time compilation, memory management, security, and exception handling. It is important to note that the .NET Framework will only run on appropriate Windows operating systems and must be installed in its entirety on the target computer. There have been many versions of the .NET Framework released since its inception, and they are able to run side by side on the same computer. The latest version of the .NET Framework at the time of writing this tutorial is .NET Framework version 4.7. Let's go back in time again, to June 2016, when the first stable version of the .NET Core runtime was released. It can be described as a cross-platform, more agile, modularized, lightweight version of the .NET Framework. It supports appropriate standards so that multiple languages can run and be managed within the .NET runtime, and also provides language interoperability. Each .NET Core language compiles into the Common Intermediate Language, or CIL. .NET Core provides some of the standard framework class libraries, which can be called the Core FX and can be described as a partial fork of the framework class libraries. .NET Core's virtual machine can be referred to as Core CLR or Core Common Language Runtime, and it provides services like improved just-in-time compilation, memory management, security, and exception handling. Unlike the .NET Framework, .NET Core can run on macOS, Linux, as well as Windows. .NET Core also provides a modular framework so that only the modules that your application uses are shipped with your application. An important difference between .NET Core and the .NET Framework is that you no longer need the entire .NET Framework installed on the target computer, but only those components of the .NET runtime that your application needs. This is why .NET Core is often referred to as a more agile version of the .NET Framework. .NET Core is open source software which makes things like the bug fix release process more efficient. It is optimized for the cloud. It is designed for high performance, provides a great base for microservice architecture. It is designed to be highly scalable. .NET Core is definitely a significant evolution of the .NET runtime, but it must be noted that it does not replace the .NET Framework. Please see in the description below a URL for a Microsoft Docs webpage containing recommendations for when to use the .NET Framework and when to use .NET Core as the .NET runtime for your server applications. We are now going to use Notepad and the .NET Core CLI, which stands for Command Line Interface, to create our Hello Name application. The command line interface is installed when you install the .NET Core SDK, which stands for Software Developers Kit. Please see details on where you can download this free software in the description below. First, let's verify the version of the .NET Core SDK installed on this computer. To do this, we type .NET and the appropriate option, so we type --info. As you can see, on this computer, .NET Core 2.1.4 SDK is installed, and version 2.1.2 of the .NET Core runtime is installed. In order to get a list of all available project templates, we type the following: .NET New. As you can see, we have a variety of project templates listed below. And we can see the various options that are applicable to this command. We are only interested in the N option, which allows us to name our project using the CLI. If you don't use the N option to give your project a specific name, your project will be given the same name as your current directory. We can use the project template short name to indicate what project template we want to use for our project. Let's type our command: .NET new console-n hello-name CLI. We'll append CLI as a suffix to our project name to identify that we are using the CLI to create this project. And you can see the necessary files for our project are automatically generated for us. First, let's verify that our project directory has been generated. We want the directory that has been generated for our project to be our current directory, so we type cd hello-name CLI. Let's take a look at what files have been automatically generated in this directory. We can see the project file with the csproj file extension. And we can see the program.cs file, which is the file we'll amend with our custom code. But let's see what code has been automatically generated in the project.cs file. As you can see, by default, the Hello World code has already been generated for us. Let's run this code before we customize the project. And by default, the application outputs Hello World to the screen. Let's add our hello name code. We are going to use Notepad as our code editor, so we type notepad program.cs so that we can edit our code in Notepad. To save time, I've already copied our code to the clipboard, so we'll paste that in and save our file. Now let's run our code. And it is essentially the same experience as when we created the project using the Visual Studio IDE. Before we move on, let's look at the files that .NET Core has created after we have built and run our application. We'll use Windows Explorer for this purpose. So we type explorer dot to see our current directory with Explorer. And as you can see, there is a bin directory for our compiled code. There is a debug directory which has been created by default. We can see here a directory named NET Core App 2.1. The runtime and the version of the runtime are included as part of the directory name. And within this directory, our DLL assembly file has been created, which is the same name as our project name, hello-name CLI. I want to give a broad overview of what a .NET assembly is. So what is an assembly? This definition comes from a Microsoft Docs web page. I've included the URL for this web page in the description below. Assemblies are the building blocks of .NET Framework applications. They form the fundamental unit of deployment, version control, reuse, activation scoping, and security permissions. An assembly is a collection of types and resources that are built to work together and form a logical unit of functionality. An assembly provides the common language runtime with the information it needs to be aware of type implementations. To the runtime, a type does not exist outside the context of an assembly. A .NET assembly can be an executable file with a .exe file extension or a dynamic link library file with a .dll file extension. Let's take a quick look at the makeup of an assembly. Metadata. Metadata essentially means data about data. This data describes how the elements in the assembly relate to each other. An important feature of an assembly is that it is self-describing. This is achieved through its metadata. Common Intermediate Language. I think Wikipedia defines this well. The Common Intermediate Language, CIL, formerly called Microsoft Intermediate Language, MSIL, is the lowest level human-readable programming language defined by the Common Language Infrastructure Specification, and is used by the .NET Framework, .NET Core, and Mono. Mono is beyond the scope of this tutorial, but is essentially another implementation of the .NET runtime. Resources. Additional resources can be compiled into an assembly. For example, if you wanted to store a JPEG image in an assembly, you are able to include this file as a resource. I also want to give a broad overview of how your .NET code is processed. We have our C# code, or we have our VB.NET code, or another .NET language, could be C++ or F#, for example. We then compile our .NET code using an appropriate compiler relative to the .NET language we have used to write our code. It could be the C# compiler, also known as CSC. It could be the VB.NET compiler, also known as VBC, or another compiler appropriate to whichever .NET language we are using. The appropriate compiler then compiles your code into an assembly which contains the common intermediate language code. If the code that has been loaded has not yet been compiled, the common language runtime will employ the just-in-time compiler service to compile the common intermediate language code into machine code that your CPU can understand. Right, we are now in the macOS environment. We are going to create our Hello Name project using .NET Core with the CLI and Visual Studio Code as our code editor. Visual Studio Code is a lightweight code editor provided by Microsoft. Details of where you can download this for free are provided in the description below. First, we'll launch Terminal to access our .NET command line interface, and let's quickly verify our current directory. Great, that's as expected. We can then verify our .NET Core information by typing .NET followed by --info. We can see that we have the .NET SDK 2.1.4 installed as well as the .NET Core Runtime 2.1.2. Now we want to see what project templates are available for us to use. We type in .NET New. As we can see, we have a variety of templates to choose from. We also have our relevant command options we can use when creating a new project. We are interested in the N option so that we can give our project a custom name. If we don't include this, it will give our project the same name as the current directory. So let's create our project. .NET New console-n hello name code. You can see it then generates our relevant application files for us. Let's make our newly created project directory our current directory. And let's verify our current directory. Okay, great. Now all we need to do is type code space dot to launch Microsoft's Visual Code Editor for Mac. Note, there is also a free version of this editor for Windows. Please check the description below for details. And we can see program.cs is available for us to customize with our code, but by default, Hello World code has been generated for us. Visual Studio Code is prompting us to include missing assets so that we can debug and build the application with VS Code. We'll just say yes to this prompt, but in this case, we are just using VS Code to edit our code, and we are going to use the CLI to build and run our application. So let's copy our code over the code that was automatically generated. Let's save our changes and use the CLI to run our code. And the result is as expected. We've now run the same code we created with C# on our Windows PC on a Mac PC. And not only that, but we also created our code on these two disparate platforms, showing the flexibility of the .NET Core runtime. And lastly, for good measure, let's create our Hello Name project using Visual Studio IDE for Mac. First, let's create a new project. Here we see a variety of project templates available in Visual Studio for Mac. You can create mobile apps for iOS and Android platforms, MVC web applications, and many more. Let's select our console.NET Core application. We are able to target which version of .NET Core we wish to use. Note the .NET framework is incompatible with the Mac platform, so we have to choose the .NET Core runtime here. We have a choice between version 2.1 and 2.0. Let's choose the latest version 2.1. Right, let's type in our project name. You will observe that the solution name is simultaneously updated with each key press. You are able to change the solution name independently. For example, if your solution contained multiple projects, it would make sense to have a name representative of the entire solution, rather than one project. So in this case, we'll leave the solution name as the same as our project's name. You will observe that our code to output Hello World is automatically generated once again. On the left-hand side, you can see our Solution Explorer window and the dependencies that have been automatically included in our project. Let's copy over the automatically generated code with our custom code. And the result is as expected. Let's summarize what we have discussed in this tutorial. We have written a very basic C# application and discussed some of the important elements pertaining to our C# code. We coded this application using 4 different code editors to demonstrate that our .NET code is not tightly coupled to any one particular code editor. We also ran our .NET code on a Windows operating system as well as a macOS platform. We discussed that our code was cross-platform because we were using .NET Core as our runtime environment, and that this would not have been possible using the .NET Framework. We broadly looked at the .NET Framework runtime and its more evolved counterpart, .NET Core. We briefly looked at .NET assemblies, which are the fundamental building blocks of .NET applications. We also briefly discussed how our code is processed by the .NET runtime. Thank you, and I hope you've enjoyed the first part of this C# for Beginners course. If you feel this tutorial was of value to you, please like this tutorial by hitting the thumbs up icon. And please subscribe to this channel to receive notifications of new content, which will be coming soon.